Hello friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video, we are going to draw root locus for the case of repeated poles. Now what is this repeated poles? When two poles lie on a single point. We are also going to understand what are the conditions to calculate angle of asymptote, centroid, breakaway point and angle of departure. Let us first observe what is the given open loop transfer function. Now this open loop transfer function is given in the form of g of s into h of s. But here this is the case of unity feedback and h of s is equal to 1. So equation is g of s is equal to k in bracket s plus 0.5 divided by s square in bracket s plus 4.5. Now what is the first step? First step is to find out the number of poles and number of zeros. Now to calculate the number of poles we have to take the denominator in the form of s. So here is the equation from denominator in the form of s. So I will equate it to 0. So I will write here s square s plus 4.5 is equal to 0. So we can say that therefore s square is equal to 0 and s plus 4.5 is equal to 0. Now when I take square root here on both the sides, then we can say that here s square is equal to 0. That means s is equal to 0 and s is equal to 0. So I will write here as a repeated poles. Therefore s is equal to 0, but at this 0 there are repeated poles. Because at this 0 point there are 2 times of s, that is 2 roots are there. So we have to draw here 2 times of poles. And here s is equal to minus 4.5. So these are the roots. So here in bracket I have written repeated poles. You can also write s is equal to 0, s is equal to 0 and s is equal to minus 4.5. So I will write here, therefore from all this we can write s is equal to 0, 0, minus 4.5. So there are total 3 roots. So we can say that number of open loop poles, notation is n, that is equal to 3. Now we will write the number of zeros. So number of zeros, for that we have to take the equation in terms of s from the numerator. So in numerator there is s plus 0.5. So we can write therefore s is equal to 0 and therefore s is equal to minus 0.5. So number of zeros, that is equal to 1. So we will write here that is equal to 1 and 0 lies at s is equal to minus 0.5. Now we will plot these open loop poles and open loop zeros. Now for the poles there are 3 poles and here 1 0 is there. Now for 3 poles we have to take the repeated poles at 0. So I will take here 2 poles. Now I will show these poles with the help of cross sign and I will show this 0 with help of this 0 sign. Now for this cross sign I have to take here 2 poles. So I will make here double cross at the 0. So here is double poles are there. Then at minus 4.5. So in between minus 4 and minus 5 there is the point minus 4.5. There is also pole. Now these 3 poles are getting completed. Now there is 1 0. So we have to show 1 0 at minus 0.5. That is in between 0 and minus 1 there is 1 point and we have to show here 0. So this 0 is also getting completed. So from these poles we can say that number of branches, that is equal to number of poles, and therefore we can say that number of poles, that is equal to number of branches, and which is equal to 3. So I will write here number of branches, that is equal to 3. Now what is the next step? So here first step is getting completed. We have to plot poles, zeros and from the number of poles we can say that the number of branches, that is equal to 3. Now next step, all these 3 branches originates from the open loop poles and terminates to zeros, and remaining branches terminate to infinity. Now if we observe here, there are total 3 branches. Out of 3 branches, 1 branch will terminate at 0 because only 1 0 is there, and remaining 2 branches will terminate to infinity. So we can say that here for this case, number of branches terminate to 0, that is 1. Number of branches terminate to infinity, that is 2. Then we will move for the next step. Now in this step we have to decide how many points or range of points which are the part of root locus. So what is the rule for that? The range of points for which to their right hand side total number of poles and zeros is equal to odd number, then those range of point or that range of point we can say is the part of root locus. Now we will use here trial and error method. Now odd number means what? Odd number means number 1, number 3, number 5. Now if I take any number in between this 0 to 0 minus 0.5, because here it is, this number is at minus 0.5 and here it is minus 4.5. Now we will use here trial and error method. Now if I take any random number in between 0 to minus 0.5, then on this number to the right hand side there are 2 poles. Now these 2 poles, that is even number. So the range of points in between 0 to minus 0.5 does not lie on the root locus. Now after 0.5, if I take any random number in between minus 0.5 and minus 1, so for that point on the right hand side, how many number of poles and zeros? That is 2 poles and 1 zero, that is 3 numbers, that is the odd number is there. So this point will lie on the root locus. So in the same way, all the points in between minus 0.5 up to minus 4.5 lie on the root locus, or those points are the part of root locus. Now if I take any point after minus 4.5 and minus 5, then what is happening on the right hand side of this point? There are total poles and zeros here, 1, 2, 3, 4. That means this is even number. So these points does not lie on the root locus, or these points are not the part of root locus. So what is the range of point which is the part of root locus? That is in between minus 0.5 to minus 4.5. So we have to write this range. So the range of points which is the part of root locus is from minus 0.5 to minus 4.5. Now I will show this range of points with the help of black marker. That is, I will make here one line. So all these points are the part of root locus. Now I will tell you some important tips when to calculate angle of asymptote, centroid and breakaway point. So when the branches terminate to infinity, these branches move along the asymptote, and that's why we have to calculate the angle of asymptote. So for this question there are total 2 branches that will terminate to infinity, and we have to calculate the 2 angle of asymptote. Now when to calculate centroid? So this asymptote is having point of intersection on this real axis. So when we apply the formula of centroid, then we will get the point of intersection of this real axis for the asymptote, and then we can plot this angle. So for this question there are 2 asymptotes, and we have to find out what is the point of intersection of these 2 asymptotes on this real axis. Now we will move for the third important point, that is breakaway point. So what is this breakaway point? So it is the location of point on the real axis from where branches depart. So we know that the branches originates from these open loop poles, and we have to check whether the branches which are originated from the open loop poles are getting departed from this breakaway point on real axis, or they are moving away from the real axis. That we have to check, and for that we have to first calculate the breakaway point. Now we will move for the calculation of angle of asymptote. So here is the formula: 2q plus 1, 180 degree divided by n minus 1, n minus m. Now here q is equal to 0, 1 up to n minus m minus 1. So here n is 3 minus 1 minus 1, that is 3 minus 2, that is 1. So we have to select the range from 0 up to 1. So we have to take range up to this number. So I will take here q is equal to 0 and q is equal to 1. So if I put here q is equal to 0, then what is the answer here? N is 3 and m is 1. So 3 minus 1, that is 2. So 180 divided by 2, that is here 90 degree. And when q is equal to 1, so if I put q is equal to 1, that is 2 plus 1, that is 3 multiplied by 180 degree divided by 2, that is 270 degree. So these are the two angles. Now for these angles, this is the angle made by asymptote. There are two asymptotes. Now we have to find out what is the point of intersection of this asymptote on this real axis. So for that we will move for the centroid. So what is the formula? Summation of real part of pole minus summation of real part of 0 divided by n minus n. So what is the real part of pole? So for that we have to select the real numbers. So all these poles lie on real axis. So we can say that here is the all the numbers are real numbers. So 0, 0. So summation of real part of pole. So I have to take all this summation, that is 0 plus 0. Now here this real number is minus 4.5. So I will take minus 4.5 minus summation of real part of 0. So here is only one 0 and it is at minus 0.5. So I will write here minus 0.5 divided by n minus n. So n is 3 and m is 1. So I will directly write the answer, that is 2. Now when we calculate this, we will get here minus 4.5 plus 0.5 divided by 2, and which is equal to minus 4 divided by 2, which is equal to minus 2. So we can say that the centroid lies at the minus 2, and we have to take this minus 2 as a center, and we have to plot the angle, that is 90 degree and 270 degree. So 90 degree means what? We have to draw here vertical line. So I will show here the asymptote, and 270 degree, that means here. Now we have to take the angle from this real axis. So here is the angle 90 degree, and this total angle from this line only we have to maintain the other angle, that is 270 degrees. So this angle is 270 degree, and we have to draw this two asymptote, and the point of intersection is minus 2, and that is the centroid. Now we will move for the calculation of breakaway point. So this breakaway point is the solution for dk by ds is equal to 0. So we have to find out this solution. Now this value of k we have to take from the characteristic equation. Now if we observe, this given question is open loop transfer function, that is with unity feedback, and that's why here g of s is equal to k in bracket s plus 0.5 divided by s square s plus 4.5. So what is the characteristic equation? It is 1 plus g of s into h of s, but feedback is unity, so we will take here 1 plus g of s. So we have to take this 1 plus and this given question. So this is the characteristic equation, and from this characteristic equation we will find out the value of k. Now if I take this characteristic equation is equal to 0 and I will transfer this 1 to the right hand side, so it will become minus 1, and then I will transfer this denominator, so this denominator will move to the numerator, and then I will move this numerator in form of s, so this whole bracket will move to the denominator. So this is the value of k. So here k will remain on one side and all the other terms to the other side. So this is the value of k. Now we will simplify this. I will multiply here s square inside the bracket, that is s cube plus 4.5 square divided by s plus 0.5. So minus 1 will remain outside the bracket. Now we have to find out the solution dk by ds, and then we have to equate it to 0. So if I take or if I differentiate these both the sides, then how we can differentiate this? So here on the left hand side there is k, so it will take dk by ds. So on the right hand side I will take minus 1 as it is. So this numerator and denominator both are in terms of s. So how we can differentiate this? We have formula, that is denominator constant, we have to differentiate numerator with respect to s, minus numerator constant, and then we have to differentiate with denominator with respect to s divided by denominator square. So here we have to put square. So what is this? So denominator s plus 0.5, it is constant, multiplied by, we have to take the differentiation for this numerator, 3s square plus, now here 4.5 remain as it is and s square is having 2s, so 4.5 multiplied by 2, that is 9s, minus, we have to take numerator as it is, that is s cube plus 4.5 s square as it is, multiplied by, we have to differentiate this denominator. So here only one s term, so for this 1s it will become only 1, and for this 0.5 it will become 0 because this is constant, divided by denominator square, that is s plus 0.5 square. Now we have to show this solution is equal to 0 because breakaway point is for the solution of dk by ds is equal to 0. So when I take the solution is equal to 0, then I will transfer this minus sign towards right hand side, then it will become 0. I will transfer this denominator to the right hand side, then also it will become 0. So we have to simplify this numerator only. So I will multiply with these two brackets with each other, and I will multiply this minus sign inside the bracket. So s multiplied by 3s square, that is 3s cube plus 9s square plus 0.5 multiplied by 3, that is 1.5s square plus 0.5 multiplied by 9, that is 4.5s. Now I will multiply here minus, that is minus s cube minus 4.5s square. Now if we observe, here are two terms for s cube, 3s cube minus s cube, that is 2s cube, 9s square, 1.5 square and minus 4.5 square. So 9s square minus 4.5 square, that is 4.5 square, plus 1.5 square, that is 6s square. And here 4.5s, that is plus 4.5s, we have to take as it is. Now I will take here 2s as a common from this equation, that is 2s inside the bracket, s square plus 3s plus 2.25. Now how we can solve this? So we will use here formula for the second order equation, that is minus b plus minus under root of b square minus 4ac divided by 2a. Now what is this ABC? ABC is coefficient of s square, that is 1. Then b is coefficient of s, that is 3, and c is constant. So if I put all the values, that is minus 3 plus minus square root of b square, that is 9, minus 4ac. So 4 multiplied by 2.25 multiplied by 1. So here is also minus 9 divided by 2 into a, that is 2. So 9 minus 9 0. So we will neglect this square root term because it is 0. So only answer is minus 3 by 2. So this is the answer for s square. S square is equal to minus 3 by 2. So we can say that what is the value of s. So suppose I will take this question as a 0. Then here answer is if I take 2s is equal to 0, and if I take this bracket, 4 bracket, s square plus 3s plus 2.25 is equal to 0, then what is the answer here? One root is s is equal to 0, and for this other root we have to take s is equal to minus 3 by 2 and s is equal to minus 3 by 2, comma s is equal to minus 3 by 2. So we can say that these are the three roots. Now we have to check whether these points are the real part of root locus or not. Now if we observe this 0, now for this 0, this point 0 does not lie on the path of root locus, because I have shown all the points which are part of root locus with the help of black marker. Now minus 3 by 2. So minus 3 by 2, that means if we calculate this, we have to take a calculation, that is it is minus 1.5. So this minus 1.5 is the part of root locus, because I have shown with the help of black marker. So we have to take here, select here the point minus 1.5, and which is the breakaway point. Now we are going to understand whether we have to calculate angle of departure for this question or not. Now if we observe, this is the breakaway point, here is the centroid, and this is the case for repeated poles, and these poles lie at the point 0, that is at origin. Now when the branches will start from these two poles, that will move towards the breakaway point, and from this breakaway point these two branches will terminate to infinity along with line of asymptote. Now when the branches will move or originate from the open loop poles and will move towards the breakaway point, from which angle they will move, that we don't know, and that's why we have to calculate the angle of departure. But what is the condition for the calculation of angle of departure? That is, poles does not lie on this real axis and imaginary axis, and poles should be symmetric about the real axis. So here poles are not symmetric about the real axis, but it is at the origin. So we will make here some construction, that is, I will take here, or I will slightly displace these two poles away from this real axis. That means we will take here some horizontal distance and vertical distance. That distance should be very small. So I will reconstruct here the diagram. I will take here the two poles. So this is the construction. Now this is vertical distance from this real axis, and horizontal distance from this imaginary axis is very small. That means here slight displacement of poles is there. Now we will apply here the condition. So for these two poles, if we observe, these two poles are symmetric about the real axis. That is, the upper portion and lower portion about this real axis is same. Now we can apply here the rules for angle of departure. So what is this formula for the calculation of angle of departure? So for that we have to select one pole as a reference pole. So I will select here this pole as a reference pole. Now we will apply the formula. So theta d is equal to plus minus 180 minus, in the bracket, summation of angle of poles made with respect to reference pole minus summation of angle of zeros made with respect to reference pole. Now if we observe, here is very slight displacement. Now here is one pole. If I connect this pole towards this, the angle is approximately 0. So if I join these two poles, then this is very small angle from this real axis. So we will take here angle that is approximately equal to 0. So I will again write here plus minus 180 minus, in the bracket. So first angle made with this pole, that is equal to 0. Then second pole. So we have to add because we have to make the summation. Now second pole is here, that is slightly below. So if I join these two poles, then we have to measure the angle. So here with this horizontal line, what is the angle? That is 90 degree. So I will write 0 plus 90 degree minus, now summation of angle made with 0 with that reference pole. So suppose if I join this 0 and this pole, so here is very small vertical distance. So again we can say that this is very small angle, so we will consider this angle as a 0. So again I will write 0. If I calculate this, plus minus 180, here minus sign we have to multiply inside, minus 90. So plus 180 minus 90, that is minus 90 degree, and plus 180 minus 90, that is plus 90 degree, and or we have to take minus 180 minus 90, that is minus 270 degree. So we can choose any one angle. So I will choose this plus 90 degree angle. So we have to show the angle of departure from this reference pole as a 90 degree. So how to take? So from this real axis we have to take the angle. So here is the real axis. So 90 degree angle, this is horizontal line. So we have to select the vertical line. So plus sign is there. So we have to take in this direction. So I will make here plus 90 degree angle. So this is the angle of departure. Now we will move for the second pole. So for the second pole we have to just change the sign. That is, for the second pole we have to take the angle that is equal to minus 90 degree or plus 270 degree. So minus 90 is also easy to take. So for the second pole we have to take from this real axis. Minus 90 means what? We have to take the angle in the downward direction. So here for this vertical line in the downward direction, this is minus 90 degree angle. So this is also the angle of departure. So we can say that when the branches originates from these two poles, that is the repeated pole, then they will move along this angle of departure and then move towards the breakaway point. So these two branches will move towards the breakaway point and then they will depart from this breakaway point towards the infinity along the asymptote. So I will draw here. Then what about the third branch? So third branch will start from this open loop pole and terminate to 0. Now while it is moving its path, that is the points on that path should be the part of the root locus. So I have shown the points which are the part of root locus with the help of black marker. So we can say that all these points are the part of root locus. So we have to show with the direction, that is branch will start from this pole and end towards 0. So here is the one branch. So I will say this is the first branch. Now we will draw second branch. So second branch is from the poles which are repeated at 0. So I will draw here one branch that will move along this angle of departure, that is 90 degree, and then move towards the breakaway point and then move along the asymptote. And then from this point it will move towards the infinity along asymptote. Now we have to show direction also. So direction, it will originate from this pole and then here. Then we will move for the third branch. So this is the second branch. So third branch also originate from this pole, move with the angle minus 90 degree and then move towards this breakaway point and terminate to infinity along this asymptote. So this is the first asymptote, this is the second asymptote. So we have to show direction also. And then it will terminate to infinity. We have to show direction. So this is the third branch. So all the three branches are getting completed.